right? So therefore, 2 theta, we going to put in cos PL, okay, minus 1, not minus, equal to 1 minus 2 sine squared PL over 2. Okay, and let me put a bracket. Okay, so once now we're going to slightly rearrange this. So we have 2 sine squared, right, PL over 2, and this is equal to 1 minus cos PL. So this is our equation number 8. Okay, so this term looks very familiar. So now this term over here is the same term that we have over here. So later on, what you'll see, we'll simplify our expression. Okay, we'll simplify our expression. So we're going to substitute, okay, both equation 7 and 8. Okay, we're going to put 7 and 8 into equation number 5. Okay, so equation number 5 is what you see over there. So we have 2a. So in that sense, we have 2a, right? So 2a sine PL over 2 cos PL over 2. Right? And the whole thing will be equal to 2e sine squared, right? PL over 2. Okay. So we can get rid of our sine PL over 2. Okay, we can get rid of this. We can get rid of the squared, right? Likewise, we can get rid of the 2's. Okay, so therefore, our a, so we have a cos PL over 2, and this will be in term equal to e sine PL over 2. So we can let a, right? So therefore, a is equal to e tangent, right? PL over 2. Okay. So we have determined what is our a. So therefore, our unique solution, okay, our unique solution will be y as a function of x, and this will be e tangent PL over 2, okay, and then we have sine px, right, plus by e cos px, and then we have minus e. And then what we do, we are going to gather all our terms. So our e, okay, so we have e, and then this will be equal to tangent PL over 2 sine px plus by cosine px, okay, because we take out and minus 1. And this is equation number 9. And this equation is only true when x is equal to 0. X is equal to 0. Our y is equal to 0. And x is equal to L. Y is also equal to 0. Okay. Now, we are also aware, okay, so from this expression over here, right? And yeah, so we are aware that y max Okay, I'm going to go to the next slide now. We're also aware that Y max occurs at X when X is equal to L over 2. Okay. So therefore, equation number 9 becomes, okay, it becomes Y max will be equal to E, right? Then we have tangent, we have PL over 2, and then we have sine PL over 2, and then we have plus cos PL over 2, small p here, not a big P, and then minus 1. Okay. Then from here we can rearrange this slightly, right? So this will be equal to E. So you can have sine PL over 2, sine PL over 2 divided by cos PL over 2. And then you can plus cos squared PL over 2. And then you divide by cos, right? PL over 2. And then down here you just leave the minus 1. So in this context, what we have will be equal to E. You can have sine squared small PL over 2. My L and my 2 almost look the same. Okay. Plus by cos squared PL over 2 divided by cos small p big L over 2. Okay. And then the whole thing will be equal to minus 1. So this happened to simplify things a lot for us. So note that cos or sine squared theta plus by cos squared theta is equal to 1, right? So therefore, our Y max can be simplified to be equal to E, and then we have 1 over cos small p big L divided by 2, and then minus 1. Okay, and then we can rewrite this to be equal to E secant, right? PL over 2 minus 1. So that is our Y max. Okay, and then if we were to consider, so this will be our equation 9a, right? So now if we were to consider or note, we know that earlier we wrote that small p is equal to square root p over ei. Okay, big P now. We wrote this earlier, right? We wrote this, yeah, we wrote this over here, right? Right. So what you see now is going to be your, so this is small p. We have our capital P now. So therefore, Y max now is also equal to E secant, okay? And then we have square root bracket square root P over EI. And then we have L over 2, and then minus by 1. Okay. Now, what we are going to do next is, in order for, or I'm going to rewrite this equation. I mean, nothing major. So this will be 1 over cosine, right? Square root P over EI, right? Multiplied by L over 2 and minus by 1, okay? And we know, okay, we know that Y max will tend towards infinity, right? Y max will tend towards infinity when cos pi over 2, right, is equal to 0, right? 1 divided by 0 is infinity. So we know that we can equate cos, right? And then we can put in square root P over EI multiplied by L over 2. Okay. So we are going to remove both the cos. Okay. Now we are writing this condition because we want to know what is Y max. And we know Y max tends towards infinity when the denominator is equal to 0. For the denominator to be equal to 0, we have to have pi over 2. So from here, we can, like what we have done before, we have this expression where we have P over EI, right? And then we have L over 2, and this will be equal to pi over 2. Okay. So we can cancel the 2. So this expression will be square root P over EI, and this will be pi over L. So P over here will be equal to pi squared EI over L squared, right? And you have seen this. This is familiar, right? Over here, this expression over here is the same. So pi squared EI over L squared. This expression over here is also seen, like what I told you, the similarity is between centric load and eccentric load is pi squared EI over L squared. So that is the common thing. Okay. So from here, like before, right? So we can call this the critical load for eccentric buckling is also equal to pi squared EI over what? L squared. Or we can also call EI is equal to the critical load L squared over pi squared. Then we can have that. Okay. So this is our equation number 10. Okay. So from here, from equation number 10, we're going to substitute equation number 10 into our equation 9b. Did I write 9b? I did not write 9b. So E secant, can you all call this equation 9b, please? My bad. Okay, this is equation 9. Okay. So we're going to substitute. Okay, we're going to substitute equation 10 into equation 9b. Okay, we're going to, so we have Y max. So 9b is equal to E, and then you have secant, then you have a square root P over EI, okay, L over 2, and then we have this whole thing minus 1. Okay, so that is our equation 9b. Let me check. That is our equation 9b, exactly the same. Okay, so from here, we know EI is equal to PCR. Okay, so therefore, now this will be equal to E secant Okay, we have square root. Okay, P divided by PCR. And then we have our L squared. And then we have our pi squared. And then we multiply L over 2. And then the whole thing minus.